So basically, if you ever played the game Snake, Snake. I watch these videos where people try and program the AI to play Snake, and what characterizes a good Snake AI? Because when I look at a Snake video, nice Snake tasks, nice Snake with like pre-programmed inputs and all that. What I want to see is I want to see the snake go all the way around. I want to, if it's the kind of snake where it's on the grid, the grid, you go up, down, left, or right. The video I want to see is the video where the snake fills up the entire screen. That's what I want. And eventually, the snake just starts chasing its own tail, and it becomes very what's the word? Deterministic. There's a point at which the game becomes very deterministic. Deterministic. It literally just follows the path of its own tail. There's no point. There's no point for a computer or a player really at that point. A player, if they have perfect control over the snake, which is always the problem when you play Snake, you don't have perfect control over the timing. It's a game of timing. Computers have perfect time. Anyway, it follows its own tail. Whether you're a computer or you're a player, there's a point at which the following your own tail becomes the perfect strategy of play. And so, why isn't that the perfect strategy of play from the outset? Why can't you just determine a path that covers the whole screen and just follow that, X times, where X is the number of dots that appear that the snake can eat, or fewer if there's more than one on the same path. Because that'll get you to the end goal. That'll get you to. It's just so trivial. You just find a path, and it just travels along that path. It's not really interesting. What's more interesting for a snake AI is to do it quickly. Is for it to reach the point where it covers up the whole screen as fast as possible in the fewest number of moves possible. And so you might say for any. So the snake when it reaches a dot, it reaches the dot, it eats the dot, and then another dot appears somewhere else on the screen. And you might think that for any given pattern, the location of where each dot appears as the previous one is eaten, or the next dot appears as the current one is eaten, is random. It's not supposed to be predictable, and that's what gives Snake its replay value. It's random, it's different every time. It's like solitaire. It's different every time. It's random, but theoretically, there's a finite number of different orders that the food can be dropped on, right? If it takes 100 dots, 100 dots for the snake to eat, in order for the snake to fill up the whole screen, then theoretically speaking, say there's, what is it, I don't know, 20 by 20 square, 400, 400 to the 100th power, that's how many different configurations, the different permutations that the dots can fall under in a given game of Snake. That's the number of different permutations. So that's in a way of thinking about it, that's the maximum number of different Optimum Snake AI plays different, if you program the snake, to move around, for every, the optimum route is going to be different for each permutation. So, but there and there is an optimum route for each permutation. So there will be 400 to the 100th power different optimum routes, but that's wrong. There are actually fewer optimum routes than that, because the dot, I know it sounds like I'm just thinking of this, it's a roundabout. I've been trying to get this the whole time. I'm just slow. Because the dots cannot spawn on the snake's body is my point. So, say the snake starts with a length of 4, increases. Okay, so if it starts with a length of 4, the field is 400 dots wide, and that's 99. 99 dots. If you eat a dot, your length increases by 4. 99 dots you eat to fill the screen. 99. And so, ideally speaking, technically there is a maximum, there is an ideal route for every configuration of points. Even, it's less than the number I said, but for each permutation there's a different ideal route. But the thing is that the route changes the permutation. I'm not sure about that, but I think it does. I mean, technically 99 dots are going to fall on the screen, regardless of what happens. But the ideal route, so there might be some sort of pattern ideal routes that prevent the dots from appearing, that can predict the ways that the dots are prevented from appearing on certain parts of the grid because of the snake's body being there. My point is that the snake's body, the player or the computer controls the snake, and therefore controls the places where the dots can possibly fall, and therefore controls the possible ideal routes. So a player controls its own fate. The computer controls its own fate. The computer has an effect on the environment that it itself is supposed to respond to and adapt to. And real life is the same way.